All right, as I started to say, just pass those down. Today we're going to do I'm going to go back behind here.
Yeah, I was about to say.
Today we're going to do a lab, density lab, and what's density equal to?
Mass
Mass over volume. And I'm going to go ahead and just move this out of the way. Since we want mass over volume. So, the first thing we're going to do is get the density of a solid. In your basket, in your, what do we call tray, in your basket will work. Okay, you have 4 metals. Okay? The first hypothesis that you need to fill out.
Can we touch them?
Yeah, you can, yeah. That's why everybody's got their own individual.
You gotta like spray them down after
You actually are going to have to spray them and wipe them, you know, at the end. Okay? Okay, the hypothesis should be on the 3rd page, okay, which is front and back. So front is 1, 2, and the hypothesis is which one do you think is the most dense? Okay? And just state which one you think is most dense and why on that. Now, if you're calculating density, what are we going to have to measure?
Mass and volume.
Mass and volume, since density is mass divided by volume, right? Okay? So the mass is going to be easy. The little black cases contain a small balance. Okay? So we're going to measure the mass. Now, we're going to measure the mass 2 different ways. On your little small balance, and then on this bigger, more accurate balance. Mass 1 is the small balance. Mass 2 is the big balance. Okay? Now, to open that up, you got to just click it. It's kind of like girls get it because it's like a compact. Okay? There's an open. Yeah, something like that. Okay? Yeah, it just you stick your finger. There's an opening in the back on one end that you can just kind of pull the top off. It took me about 30 minutes to figure it out the other day. All right, so we're going to get the mass off with that. Then you're going to get, that's mass 1, and then you're going to get mass here on this balance, and that's going to be considered mass 2. Now, when you have a digital display, you just assume that that last digit is uncertain. Remember, sig figs, when we do measurements, it's everything that we know for sure plus 1 digit of uncertainty. The balance has that figured in. They electronically round off. They actually carry it out more places, and they round to what does it have, 2 decimal places on yours? Okay? This one's going to have 3 decimal places.
Like, how do we tell which metals?
Okay, I'm going to tell you. Okay? So, when you measure mass, okay, on the digital, you just record whatever it says. You don't have to do any guesstimation. You don't have to guess between 1 and 10 and what it's going to be. You don't add an extra 0 or any of that. Whatever the display says, but we know that the last digit is uncertain. But when we measure with the ruler, okay, you all have the ruler. And I'm actually probably going to have to this is turned on. Because one of the things that we're trying to learn in this lab is how to accurately and correctly measure with our measuring devices. So if I'm looking at this meter stick right here, okay? Can y'all all see that in the back? It looks a little blurry to me. It's a little bit better. So if I have something that I'm measuring from right here to, let's just say, right there. So that's what I measure my block to say. What do we say? How would you record this? What do we know for sure? What do we have to guess on?
It's above 2, but it's between 2 and 3.
It's between 2 and 3 for sure. Okay, but what's the small one?
It's definitely like 2.4.
It's definitely 2.4 something, right? Is it right on the 2.4?
No.
No. So we're going to guesstimate how far it is in between. Now, you're only allowed everything we know for sure. We know it's between 2.4 and 2.5. That's it for sure. So these numbers are accurately, the 2.4 we know. So we're going to guesstimate how far it is, and to me, it looks like about halfway, right? So we'd say 2.45 centimeters. All right? Yes, sir.
No, I think they're gonna answer it. Go ahead.
Okay? Now, what if it lands right here?
You say exactly 3.0.
Okay? So we know it's between 3.0 and 3.1, right? But it looks like it's right on the line. If it goes to 2 decimal places for the 2.45, the same ruler can go to 2 decimal places for any measurement on here. So it's going to be 3.00 centimeters. Because you're between the 3.0 and 3.1, but you're really not between, you're right on it, so it's 3.00. The rule is going to be this. You always go 1 digit more than the smallest line. Okay? In this case, the smallest line is 1/10, 1 decimal place of a centimeter. Which means we're going to measure to 2 decimal places to the 100ths. Now, look at your big plastic graduated cylinder. What's the smallest unit on that?
10, 12. Wait, what?
Yeah, what place? The ones place, right? Each line represents an increase of 1 milliliter. So when we measure that, what are we going to measure to?
Smallest.
The tenths. 1 past the smallest line. The smallest line is ones. So we're going to measure to the tenth. So if it's right on the line, we'd say, let's just say it's right on the 10.0 line. So here's 10. If the meniscus is right on that, we're going to say it's 10.0. If it looks like it's in between 2 lines, they're so close to one another, we're just going to call it a 0.5. So if it was between, so here's the 10 point, well, this is the 11, okay? So if it's between, we're just going to call that 10.5. Look at your small glass graduated cylinder. What's the smallest unit on that one? Tenths, right? So what do we measure to? To the 100ths. So when you're doing this and you're recording your volumes, we're going to measure with a ruler length times width and height. You need to make sure you record to the proper degree of accuracy. Then when we record the volume by water displacement, record everything in your data to the proper degree of accuracy, what we just talked about. Then we're going to do the same thing. Then in part B, that's all for a solid. Part B, we're going to do a liquid. So you're going to take your graduated cylinder. First thing we got to do is weigh it dry. Because we don't want the weight of the graduated cylinder. We want the weight of the alcohol inside the graduated cylinder. So we're going to weigh the graduated cylinder dry. Then you're going to add 3 milliliters. And it's going to be important that you get, it's a dropper bottle, that's the little plastic bottle, it's alcohol. Make sure just drop by drop you get right to the 3. And again, what do we call the curved line? And where do we measure from? The bottom of that meniscus. So get the bottom of the meniscus on the top of that line and you get exactly 3, then weigh it. Now how are you going to get the mass of the alcohol inside?
You're going to wait before and see how much it changes? Like
Or
once you
you
have
can
alcohol
tear
in it too?
You can't tear it, okay, because that's going to 0,
Oh wait, yeah, I'm thinking on the scale.
okay? But why did we measure it dry? So you can subtract it, right? Because the alcohol plus the graduated cylinder plus 3 milliliters minus the graduated cylinder is just going to be 3 milliliters. Now, you don't have to dump it out, just add 2 more milliliters to the 5, more milliliters to the 7, weigh it, 2 more milliliters to the 9, weigh it. Then when you're done, you can just take the lid off the plastic bottle and pour it all right back in because it's still fine to use. Okay? So that's all you have to do. You have to measure the metals. Now, when you're looking at these metals, the reddish brown one, what do you think it is? This one.
Brass, copper.
This is copper. Okay, so the reddish brown one is copper. The shiny gold one is brass. The dull, heavier, silver, grayish one is iron. And the light silver one is aluminum. Okay? Aluminum, iron, what's the symbol for iron? Fe, comes from ferrum. Copper is Cu, and brass is Brass. Okay, there's no abbreviation because it's a mixture of things. Okay? So you just only have to do one. So just you get to pick one, whichever one you want to do. Just make sure you label which one you're doing on the top of that data table. Okay? And then do your measurements. You kind of go from there. Did I answer your question?
You did for 3.0.
Okay.
This has a little liquid in it, I just poured it
What
into
is
the.
this?
Well, no, because you need the dry one, so just come swap it out with this one.
I didn't get one of those.
You didn't get a graduated cylinder?
Not a little one.
Huh. Well, just come get one.
Wait, what is mass 1 and mass 2? Is that like?
Mass 1 is the small one, mass 2 is on this one.
So can we go ahead and do that?
Yep. Okay, and always just make sure that it's 0, and you just always hit the, oh, I just turned it on. Hit the tab button, that's what you're supposed to hit. Now you go to the other side. Yeah.
Huh? Using this one.
Okay, now, another thing, okay? Now, the way you graduate cylinder on that, they're weighing their solid.
Do I have to like close it?
Yes, because it's so sensitive that the wind will affect it. Now, instead of trying to memorize your number, bring your sheet with you and write it down, okay? All right, for those of you at home, we're going to stop it now. You have a virtual lab. If you're full-time virtual, I just wanted you to be able to see how to measure accurately. So when you're looking at the pictures online, measure the volumes in the graduated cylinders accurately, use the ruler accurately. One past whatever the smallest line is.
Yeah, I think all